Okay, where do we use these cams and their usage about? We use, our example is a drive shaft unit, a cam drive unit. Here we have 4 followers with 2 cams on each side. Let me open the YouTube video which I have prepared for this purpose. Okay, in the cam designs, we have one cam unit. We have a follower, we have a shaft, and the shaft, on this shaft, we have inserted the cam. When we turn the cam or the shaft, the follower just goes up and down. We also have different types of cams. We first define the cam movement with this displacement diagram, okay? And in this displacement diagram, we have divided our cam into segments. In this example, we have divided our cam into 30 degrees segments. We have 12 segments here. In our example, in this example, we have divided our cam into 26 segments. Here we have 5 degrees up to 120, and after 120 we have a steady motion at that campsite. Okay. The next, in this cam, we define our follower movement with this displacement tool. Why do we use cams? If we would like to just define such a movement with the links, with the sticks, or with the joints, you have to just make 4 or more links to give that movement also. Cam simplifies our mechanisms. As you see, we have a follower, roller, and the cam. When we rotate the shaft, cam rotates with that, and the roller just moves up and down. We can define that movement. For this example, the next example here we have on the right side, this is a cam example with a valve in the engine side. We have 4 elements in a cam mechanism: follower, roller, and cam. We have defined our segments and we define the movement at that segment. In the cam mechanisms, we have a base circle, and the movement on that base circle, we just add that movement onto this base circle. This is the displacement, which we define in displacement chart, and we add that movement to base circle. We have 3 alternatives of cam design, which is one, this cam today we are going to deal with. The second one, the linear cam. This time our follower here, but our input, our is coming from the linear actuator. Here we will just push and pull with this tool to give the movement to the follower and afterwards. Also, we have a cylindrical cam design, which this time we have again a rotating tool, but this time we will just use this groove on the cylindrical cam. We will use this groove in order to give the movement in these two directions, up and down, which I'm showing on the screen. We are going to deal this cam today. Our example have 2 cams and 8 followers. I have just changed our design a little bit to show you the possibilities of the other machine elements. Also, I have just changed the design. When you look from the top side, we have a cross section on the bottom side, and I have just changed our design according to this unit. In this example, we have 3 followers. These are 3 followers which we give the movement. In these drives, we use this intermittent movement to control the movement of our mechanisms. In different intervals, we just give the up and down movement in this mechanism, and we will just change our rotation. Also, we have a conveyor system which the bags are sorted according to their properties or as we wish. We have a mechanism on the top side, and we will just rotate this arm according to our needs. And for this movement, we also use a box, a parallel drive box on the top side. And for this movement control, we use the cam drive. This is also another cam drive unit. In this cam drive unit, I have intended to show you how it is working. We have a full contact in all the cases. This cam and this cam never lose the contact between the follower and the other side. In here, we have 2 cams, and the 2 cam movement divided in this purpose. We have 4 cycle of movement. Here we have the rotation with the yellow one, and we have 2 rotation on green side, and we have 2 rotation for the steady movement. If you do not lose contact in this example, if you do not lose contact in a mechanism, then you can just change your direction into your needs. This is our exploded view, a similar exploded view, we have two cams, one shaft, two bearings on each side, and we have a seal at this point. This is our input shaft. And also we have another output shaft. In this output shaft, we have 4 followers, 4 pins, and 2 side plates. 3 side plates in this design. We have 2 bearings on each side, and we have a shaft seal at this point, which is on the left side. Again, the same movement. The drive movement, as you see, comes from this parallel drive unit. This controls our movement. Okay, everything is understood, I think. You can also interrupt me when you just do not understand, or if you want to ask questions, you can ask in Turkish or in English, whatever you want. Okay? Okay, what we are going to do is, I have a table with 5 degrees intervals. Okay, here. What I did is, I have just made that. I have also put this file into the submission. And I have just made all the entries. We have the intervals here, and this interval starts at 0 degrees and end at 5 degrees. I mean, the first interval is between 0 degrees and 5 degrees. The second interval is starting at 5 degrees and ends at 10 degrees. Also, the third one, the fourth one, and the fifth one. We have, in our table, we have 25 intervals. 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, and so on. At the end, we have 2 degrees, which is 115 and 120, and it is steady at this position, which have the same amount of stroke. This is the degrees intervals, and the other column here is the stroke interval or the base circle interval. Here, our base circle here is 3.119, okay? In inch units, of course. And I will just make that inch units converted to metric units, which is 79.222 6. It is in millimeters. Also, our stroke, this is our base circle, and after that base circle, we just start our cycle with this property. Okay? Here we have a stroke movement more than our base circle, which is 0 point. If you have open the columns, I have some values entered to these values. I have the segments numbered, and this time I will just make a new table, which is this one. I will just subtract our base circle from the given value on the table, which is this one, 3.74 inches minus, this time I have 3.119. 3.119. This is in inch units. I will just multiply this unit by the inch millimeter conversion. As you see, the stroke value, which you see in the first interval, it is 15.773. I have omitted that one here. We will just create our table. I will just hide these values to create our new CAM design. I have omitted the inch values. Okay, because I only need the stroke values to our design. I have just made a new table, which is the similar of this one. And also, when we come to our CAM design, I will add one segment which is just dealing with 120 degrees to the 360 degrees, because we also have another cycle after that point. As you see, we have a 0 degree here and 120 degree here. The other one, which is the waiting time, it is called dwell, 240 degrees. Let's open a new inventor file. This time we have the machine elements under, let me open, please open a new inventor standard millimetric, this time assembly. Okay. Sorry for waiting, because it is a slow when you share a Zoom and when you share a screen. The machine elements in Inventor, we use assembly environment and design tab. And here we have a disk cam, which we are going to create. Please just click on right click. I'm sorry, left click. The first, you may have a warning to save your assembly. Please open, if you haven't done so, please open a folder, because we are going to just create our parts into that folder, cam drive. In this mouse click, I think it's okay. You can see some movements. Okay. Also, you can just follow on the right bottom side. You can see the keyboard entries. In this cam generator, we have a component, which is the cam, which we are going to create this one. Also, we have to define the follower here. These are the follower and the cam designs. Okay. Here we have a segment information. Also, we have a graphical information here. And in this information, we have at this point, which is the lift or stroke. We have the velocity information. The colors here just indicate the blue one is our lift one, which we are going to deal mostly with it. The other possible graphics here are its derivatives according to our entries. Here, what I'm going to do is first click on each side. I will only remain the lift point here. I'm going to deal. Please just click every item and only remain the lift here. This is our stroke. As you see, we have, in my example, we have 3 segments, which is from this one, 0.2 to 90 degrees. When you just control the actual segments, as you see, we have 3 segments. And when you just go over these possible solutions, as you see, we have 3 segments. And in this 3 segment, for example, I will just deal with the second segment, the motion and position which starts from the previous one. The segment first starts at 0 degree segment till to the 90 degree, which is this one. And at this point, the lift at the end, which is the cam, has to be lifted on at the end of 90 degrees, which is 10 millimeters. After this one, in the second segment, as you see, the second segment starts at 90 degrees and at 180 degrees. And our lift will be 0, which will drop down to the starting position, which we have lifted from the 0 degree, 0 lift to 10 millimeters to upside. We will just go down 10 millimeters to the bottom side. And after that one, we have this third segment, which is this area. And at that area, we are not going to just make any movement at this point. Here, what I'm going to do is, I have 25 segments here. And I will just make all the entries, which is the first segment. First, I'm going to create 25 segments. Then I will just make the lift at those points. Also, I'm going to create another segment, which is 26, and I will remain at this point. As you see, we have a starting segment and the ending segment here, and these all have the same values. Okay? Please be sure that these two have the same segments. Also, let me correct, this is 15.77 because we have the same ending point. And at this point, we will just keep this at the 26th segment. We are going to make and stay same with this point. Okay? I am waiting for your 26 segment creation. To arrange that segments, it is not important at this point. We will just arrange our segment heights, the lift points, by using the table. We will just create first the segments, and we are going to just arrange that segments by giving the entries here. Also, we are going to make the angle adjustments. This time, I need 26 segments only. It is not important because we are going to just make our entries with manually here. When you just select the segments, as you see, I have selected the 7th one. From this one, I will just select the 21st segment. It is changing.
Hı-hı.
It is normal. No problem so far.
Tamam. Yani herhangi bir yerde 26 olması yeterli değil mi?
I need 26 segments. For me, it is enough to just make a complete 26 segments. Okay? The next thing, I will adjust the basic radius. When you just open this preview screen, as you see, we have a cam here, which is R0, okay? Which defines R0. In our example, our R0 is our base circle here, which is 3.119. And in our example, our base circle is around 7.222. I will just change this radius to metric units. With this one. Also, in our example, we also have a thickness from the top side. Let's open this one. We have the thickness 0.6. In our example, in the PDF, it is 30 millimeters. We will just make this entry, the cam width, 30 millimeters. Also the same thing, the roller has the same width. It is also 30 millimeters. Our follower here has 1.25, and this time our follower here, I will change this radius, which is 1.20 multiplied by 25.4, which is 30.5. For this one, I will just make the entry times 25.4. Okay? Which is 30.5. Okay. After this generation, please just press the calculate button. and make the OK. You will just create the first this cam body part. Okay, I'm going to start this creation again and again. I open a new assembly and I will just jump to design tab. I will design a disk cam. I have to save my assembly. I will just override on it, the old one. The next, we have a cam here. I have the old values. I have deleted this one. I have deleted all the segments. I have 3 segments, and I will divide these segments by adding before or adding after command. Add before, add after. Add after, add before. I need 26 segments. I need 26 segments. I'm not going to play with the given values here. I will just arrange that values. You may also have a warning, something like this. It is normal right now. You may have a warning, something like this. When you just open this scale, this warning, it is normal to have a warning, something like this, because we haven't just adjusted anything. The first thing I need, add before, add after. I need 26 segments. I'm going to add and adjust. If you made a mistake, you can just go to 1 and delete the one segment here. Any segment you would like to delete. Okay. When you just calculate and OK, it just asks you to make you are going to accept the solution. You may have something like this. Like this. We will arrange our camshaft. It will be something like this. We will just follow the cam like this. We will have at the end of this solution. Also, I'm going to just make, I have also previously one valve timing, something like this. In the engine, in my previous lab works, we have done, especially in the summer school, we have just done this valve timing in the engine selection. The next thing, when we have created a cam something like this, this is not adjusted. Also, we did nothing about this alignments. Here, we have just created the disk cam after you have just approved with calculation and OK. To just change the values here, please right click on this disk cam and open edit using with design accelerator. When you click, you will just go back to this disk cam component generator. Okay, I have just omitted this one because it is very normal to have a warning something like this because it has the undercuts. The profile is not very sharp and it is impossible to create a shaft, the cam something like this. Okay, what I'm going to do is I will divide my screen into two sections. Okay, and I will just go back to my figure here. I'm going to make the entries. I will just make this one and this one divided into two. Again, I will just go to edit and make the entries. My first segment starts with 0 degrees and end at 5 degrees. First, I'm just going to add the degree. Then I'm going to add the 15.77, which is the lift. Okay. The motion and position for first segment, it starts with 0 degree, which is this point, and ends at 5 degrees. And the lift at this end point, as you see, we also have different types here. You can just make any entries here. I'm just going to select the harmonic sinusoidal. We would like to have a very smooth transition between these two, between the segments. Okay. First, I have calculated. Then I will just go to the second segment. At this segment, our motion ends at position 10 degrees. I will adjust the ending position to 10 degrees. And at that point, I'm going to make that entry, which is 16.023. I'm sorry. Again, calculate. When you calculate, the position of the segment, it changes on the bottom side in this graphical screen. The next, I have another actual segment, which is the third one. The third one starts at 10 degrees and ends at 15. And the lift at the third one, which is 16.28. As you see, I'm going to adjust one by one. The fourth one, my fourth segment here just starts at 15 and adds at 20 degrees. And I'm going to add the lift at 70.3. Again, calculate. When you make the calculations here, the graphical screen changes. Okay? The fifth one, I will go to the fifth segment. This is 25, the ending position. And the lift at that point is 19.74. And hit the calculate. In every section, in every segment, please make the calculate. It just grabs that information and change at the background here. Okay? The next one, the sixth one, we have an ending position which is 30 degree. And here I have the stroke end, which is 21.32. And hit the calculate. The second 8th segment, the motion and position, it is 35 degrees. And I'm going to make 21.08. And hit the calculate. 8, I will just jump to 8th segment. It is ending at 40 degrees, ending position, and it has the 20.76. Hit the calculate. One by one, we are going to make the entries. The 9th one, 9th segment, 9 times 45, which is 9 times 5, and the stroke here, which is 20.45. Hit the calculate. The 10th one, $50, and it is ending at 20.60. Hit the calculate. 11th one, I will just change my segment, which is this time. As you see, we have a very different segment here when I have just a range. You can also, please have a look at this position. You can also just pull these segments as you wish from the bottom side in order not to make the entries. 55 here, which is 60.73. We have a very big jump, around 40 millimeters stroke in one segment. We have a very big jump at this point, which is 60.73. And hit the calculate. We have a very big jump at this point. And after this one, I'm going to change the segment 2012 here. I'm sorry. I have 60 degrees. And at that point, I have the stroke 59.46. I made that entry. You can just go on and on. Let me open the mouse indicator because I think I have lost that one. You can just continue. Okay. 12 segment, we have 59.6. For 13 segment, which is 65 degrees, and I will just arrange 65 to 70, 57.18. Hit the calculate. 14, which is 14 times 5. And I will just add 53.80. I hit the calculate. 15, it is 75 degrees. And at this point, we have 49.3 stroke.
Tamam.
I made a little adjustment at the table. Normally, you should have to just adjust that table before me. Okay, let's go back to the CAM design again. 14, 15, 16. 16, I'm going to adjust 16 times 5. And after this 16 have 44.22. I hit the calculate. 18. I will just make the entry 38.36. This time we will have a minus degrees sometimes, the lifting positions. As you see, we have a very, very, very close meeting at this point, which is the 12th segment here. The 19th, which is 16.79. Hit the calculate. 20, which is 100 degrees at endpoint. 7.14. We have a strip decrease at this point. 21. We have 105 at that point, which is 8.92. Calculate. For 22 segment, we have 110 and 12.5. 48. Hit the calculate, then which is 105. I'm sorry. For the 23rd, 125, 155. 24.25. Hit the calculate. This one 120. Hit the calculate. And after this one 25 again. Before this one we have 25, and after this segment it is 125. The 25th one, it has the stroke 15.77, and we will just return to this position. At the end here we have a starting point which comes to 0 point, and you cannot change this one. For this we will do something special, which is not to calculate this position. And accept all the other values. We have a camshaft, something like this. Also, I ignore the first segment not to be calculated. Hit the calculate and OK button. We will just change our first design. Let's make together. To this cam, edit with design accelerator. We are going to add a segment afterwards. We again have 26, not 26, 27 segments afterwards. Okay, let's start together. The first one, the first segment, it ends at 5 degrees, but this time I will ignore this to 0 and calculate. The second segment, I will just make minus 15.77. Again, calculate. The third segment, again, I will just subtract 1577. Again, calculate. The fourth segment, I will again minus 1577. Again, calculate. Fifth, minus 1577. Again, calculate. Sixth one, 1577. Again, calculate. 7 minus 1577. Calculate. 8 1 minus 1577. Calculate. 9 again, calculate. 10 15 minus 77. Calculate. 11,1577. Minus 1577. 13, 1577. 14, 1577. 15 minus 1577. 16, 1577. 17, 1577. We may have minus values. The 18th, it is 2898. Minus 77. Okay, let me check the segments. Okay. We will subtract the base circle in all values, from all values. We will just go to 0 at the end of this segment, or you can just simply write 0 for the 26. This 26 segment, you can ignore this one, and when you hit the calculate and OK button,
27. segment olmayacak mı hocam?
bakayım bir geldi mi? Kaydedeyim bakayım ne oldu. %26, bunu da kaydet. Add after, we will again use 16, and this time I will just adjust to the 26 segment to 360. $300 Let me just open this again. Sometimes we may have problems. I will open. Okay, let's correct with the previous one which I have created actually. We have 28 segments. From the first one, we have 0. The second segment, we have 0.26. The third segment, we have 15 degrees, 0.51. The next one, we have 4 segment. The fourth segment ends at 21.35 millimeter. Fifth one, we have 4.07. 6, 30 degrees, 8.64 millimeter. Seventh one, 35 degrees, 14.74. 8, 40 degrees, 22.86. 9 segment, 45, 30.74 millimeter. 10, 50 degrees, 10 segment, 50 degrees, 38.1 millimeter. 11, 55 degrees, 44.96 millimeter. 12, 60 degrees, 43.69 millimeter. 13, 65 degrees, 41.41 millimeter. 14th segment, it is 70, 38.1 millimeter. 15, 75 degrees, 33.53 millimeter. 16, we have 80 degrees, 28.55 millimeter. 18, 75 degrees, 21.59 millimeter. 18, 90 degrees, 13.21 millimeter, 19, 95 degrees, 1.02 millimeter. After this one, we will just go to negative values. 100 degrees, minus 8.63 millimeter. You have to just add minus after the 20th segment. Maybe it's my fault in the previous one. After this one, 21 minus 6.85 millimeter, which is 105 degrees. 22, 110 degree, minus 3.3 millimeter. 23rd, 115 degrees, minus 1.82 millimeter. 24, 120 degrees, minus 0.25 millimeter. 25th segment, which is 125, it is again turned to 0. Then the next thing we have 26th, again 360 to 0 degree. Lastly, we have an ignored section here. It will just have, this time you ignore. It is not to be calculated. Okay, you will change from this point. Let me check this one. First, I check the degrees here. If I made the mistake. Also, I need a segment after this one. Also, another segment. We have 25th, which is this segment. 26th. It is again 260. 360, I'm sorry. And the 28th segment, it is not to be calculated. After this creation, you can also place this one. For a cam design, for simple one. Like the engine valve timing. We have in engine, we have 4 cycles. One exhaust. One, we have, let me open the video first. We have 4 cycles. We have 4 cycles actually. In the beginning of the semester, we have made a engine design, but I'm not changing this cycle here. you see the camshafts on the top. It just arranged the timing of the opening and the closing of the valve in the section. We have 4 cycles: suction, compression, power, and exhaust strokes, which are these. We have 4 cycles here: the suction cycle, compression cycle, the ignition and the power cycle, and the exhaust cycle in an engine. Open a new camshaft. We will just make the adjustment with this cam. I'm going to close and do not save this file. Please open a new Inventor standard millimetric IPT assembly. Again, to design with this cam. This is the valve assembly, let's say. We use this timing, this timing in our example. I have ignored and deleted all the segments from the first example. Then I will remain 4 different timing. I will create 4 segments. I will divide 4 different cycles, and I will adjust those cycles. As you see, we have 1 camshaft and 2 other cycles here. This one, the inside, the inlet valve opens and closes. We have 2 timings. For this, I will just remove this time 2 timings, and inlet valve opens at this point, which is at before the 0 point. Let's call this point as 0 point. After this one, we just go to back for 10 degrees. For this, my movement just starts at 350 degrees. And after this 350 degrees, it just opens, the inlet valve opens, and it will just close up to this point, which is 180 degree plus 55 degrees. We have an opening time from the 360 degrees to 235 degrees. And after that one, the inlet valve closes, and it will just keep close to 360 degrees. For this, we have 2 types for inlet valve. Also, we have the exhaust valve. This time, our exhaust valve opens at 20 degrees because the burned fuel and air mixture just have to be taken out from the engine body here, the engine closure, and the exhaust valves must be closed up to that point, up to some point, which just make the compression begins. For this, we have just separated our movement, as you see here, into two sections. One, this cam, the cams on the right side or on the other side, just controls the opening and the closing of the valves. For this, we need 2 cycles, like here, as you see in this example. One is the inlet valve, the other one is exhaust valve, like this compression, doing this time. As you see, intake stroke, and this is the out exhaust stroke. And after the coming point, which the cylinder just goes up to this point, it will be just open because it will take time to have the exhaust gases taken out from the engine block. When we have this stroke at this point, we have an igniter here. And these cams just adjust the ignitions. We have 4 cycles: intake, compression, ignition, and exhaust. And these valves have only 2 types: one open and close. For this, I need 2 segments, and I can adjust those segments by adding these movements. Here, the left end, let's say 10 millimeter, up to with 10 degrees plus 100 plus 55, which tells me this timing. This is the 10 millimeter, 10 degrees, 100 degrees to up to this point, and 55 degrees after this 100 degrees. And after that, we have a closed cycle. And after that, lift end, which will just go to 0. I will just make the calculations. I'm sorry. 10 degrees. I may have a cycle something like this. At the end of this one, I will just make the closure at this end. When I create a cam something like this, it will be a cam something like this. For this, I need to change some parameters, especially. I haven't done so. Let's say our basic radius a little bit smaller this time, let's say 50, and the roller radius, it is 10 millimeter. Let's change the shape a little bit also. You can just make a smaller type like this. Also, you can just divide the sections here. Add before, add after, and you can adjust these movements by this, like this.